In this one, let's try to understand how to handle missing values in data using Python. Now, if you feed in garbage to a machine learning model, the chances are the results that come out of it is not going to be of good quality. Now, in real world datasets, in raw datasets especially, the occurrence of missing values is very common. So in this one, we will first try to understand the different types of missing values, the various reasons these kind of missing values could occur in the first place, and different approaches and strategies that we can use to handle these kind of missing values. While we try to understand that, we will also see in what kind of situations we want to use what type of an approach as well, and look at also the do's and don'ts when we do these kind of missing value imputation treatments. So first, what could be some of the reasons that missing values could occur? So the reason could be at the data collection stage itself, the values did not get captured properly, or it could occur systemically for some valid reason. For example, say you are collecting the test scores of students who appeared for an exam. There could be some students who did not take the exam, right? For those students, these scores might occur as missing, but actually it can be translated as the score could be as 0, or after they take the exam at a later stage, retake the exam at a different test, that score could be updated later on. So in that kind of situations where the values are genuinely missing, you could apply a rule and fill up those missing values. Or there could also be formatting issues with the data. For example, the database, when you are trying to format, say, the date field, there could be a lot of formatting issues that could happen, and that can cause a problem. Or there could be systems incompatibility. When you try to read the data from database into different programming languages, it may not be done well. So those kind of issues can also occur, leading to missing values. Now, those are some of the reasons, common reasons, but what are the different types of missing values in the very first place? On a high level, you can split it into three different types of missing values. First, very common approach or very common occurrence is missing completely at random, also called as MCAR, where the probability of missing value across all the variables is the same. That is, we are not able to assign a root cause behind why certain values are missing, or use some other variable, some sort of a logic to predict the values that might be missing in a given column in the data frame. Alright, so that is missing completely at random. Missing at random means, so the data is missing at random, but it is possible to predict that missing value using one or the other imputation approach. There are many methods to do this or handle this kind of missing values. That is what we are going to be looking at in this video, and probably the next video also. So this is another type. The third type is not missing at random. So these kind of missing values are missing for a certain reason, like the exam example like that I quoted, right? That could be one reason. So using a proper logic, if you find the root cause behind why the data is missing, you will be able to come up with what should be the logic that should be used to fill up those kind of missing values. So these are the main types. Now, what to do when the data is missing? So on a very high level, there are four things that you can do in order to handle those missing values. Okay, you have a data frame. Let's go back to our data frame based approach here. So you have a data frame, say certain rows, you have certain columns here, and a good number of rows also exist in the data frame. Alright. Now if a certain row is missing, say this is a missing value, you might want to choose to drop this entire row, right? That is one way of handling it. And if a given column existing in the data has a lot of missing values, say a lot of different values are missing here, you might want to drop the entire column from the data set itself. That is also another approach, that is approach 2. Third approach is use some meaningful method to fill in the missing values in a given column with a meaningful value. We will look at those approaches, a number of those approaches in fact. Alright. The fourth approach in general is use a machine learning algorithm to fill up these missing values. Say this particular value is missing. This value can be predicted using the information contained in other columns present in the data. Alright, we can leverage the other columns to predict what value this particular cell should hold. That is another approach we can use to fill up the missing values. There is no one best approach to use. Let's look at various scenarios on how to tackle or what kind of an approach we want to use for various different situations. Alright, first question is when to drop missing data and when to impute them. So the first two approaches that we just looked at is dropping the specific rows And second approach was dropping the entire column itself in certain cases. So when to go for this kind of a situation, right? Now, if you have a data set, it has a lot of rows. And certain number of rows, the missing value is present in less than 1% or less than 2% of the data, and you still are left with a good number of data points for you to train. So suppose there's a missing value here, there's a missing value here. After removing all those records, you are still left with enough number of rows to train your machine learning model. In that case, you might want to go for removing the entire row. That should be okay. As long as you are having sufficient number of records, you are good. All right. Similar logic applies for the column also. Suppose you have a column here, this is having a lot of missing values. It is having a lot of missing values. So these are all missing values, let's say. All right. There's a lot of missing values, and some amount of values are present as well. Now, if the situation is such that if you are going to be imputing these missing values, this is going to introduce a lot more uncertainty and a lot more incorrect data to this column. If that is the case, you are better off removing the entire column itself rather than corrupting the data set. All right. In that case, you might want to remove the entire column itself. Now, before you go ahead and remove the entire column, you might want to create a new column. Say you have decided, okay, this is having too many data points that are missing. Rather than imputing it and introduce some amount of uncertainty and corrupting the data set, before you remove that, you might want to consider and create a new column, a dummy column, which contains, in those places where the values were missing, you want to have a 1. In those places where the values are missing, you want to have a 1. In those places that are not missing, you want to have a 0, just to mark which of the data points were actually missing and which of them were not missing. All right, so you don't lose that information on which are the missing data points here. So this is one thing that you might want to consider doing. Right, this is definitely helpful. Now, you might or might not go after this. Removing this is kind of the last option. I wouldn't recommend removing the data set before you exhaust all the other approaches that might help you improve the quality of the final machine learning model outcome. All right, so let's get into various approaches shortly. Now, before we get into that, let's also see how to visualize missing values present in the data. There's a very nice package called a Missingness. So right now I'm using the Missingness package of this particular version. If you have not installed Missingness package earlier, you need to do a pip install. So when you run it in Jupyter, make sure you have an exclamation mark before pip. So pip install Missingness, that should install the latest version of this package. If you face some trouble to run this code further on, right, run this particular code because of some problem that might occur, make sure you are installing this particular version, and this should work for sure. All right, so in this package, it provides a nice matrix function. It helps you visualize amongst all the different columns that exist in the data, where are the missing values. So here there's a chunk of missing values in gender column. Here there's a chunk in age. Here is also another chunk. All right. So it won't be possible to visualize all the missing data that occur in the data set. All right. Wherever there is a concentration of missing values, that will be visible here, and these are some of the instances that occurs. All right. Some of the other columns are completely black. It doesn't mean that it does not even have one single row that is missing. It does not mean that. Just for a visualization perspective, it gives you where the missing values are on a high level. Now, one more thing we want to study is the missingness of values in one column being influenced by the missing data behavior in another column. Getting me? So a specific column has missing values. Say, let's say you have the age column here. Age is having missing values, and it's having a missing value here. It's also having some missing value here. All right, but when age was missing here, the balance is also missing at the same time for a certain number of records. But that's not consistent. Age is missing here, but the balance does not seem to be missing in the same region. All right. Now, could there be some sort of a interrelationship between two different columns that are missing at the same time? That also could be helpful, because that might be some rule that you might be able to uncover, or You could potentially use the other variable, the balance variable, if balance variable is not missing here, it could be a useful predictor to predict what the value of age should be. All right. Now, there's an irony here. When age is missing, balance is also missing. When that happens, the correlation is high. But it could still be helpful in rows where the balance is not missing and age is missing. All right. Now, keeping that in context, you have a nice function, heat map function in missing number package. Pass the data frame and you will get a nice heat map. The darker the value here, the occurrence here, it means there could be a correlation. So here there's a correlation between the missingness of the age and the gender column. All right. Some relationship could exist between these two columns that you might want to check out further. All right. Now, how to impute the missing values. Now we are getting to the core part. Now let's start looking at the various approaches one by one of how to keep imputing the missing values. On a high level, you have two options. You can impute it with the constant number. So you have a given column, you have a column in the data frame. You can impute those missing values with a constant number. There are various approaches to find this constant number. We will look at those. Alternately, you can predict the missing value using a machine learning algorithm. That is the second approach. Two high level approaches. Now, some of the approaches is listed here. We will go into this in more detail. Some of the approaches is, suppose if it is a numeric data, right? You might want to replace the missing values with either the mean or the median of that particular column, excluding the missing values. All right. Sometimes median is better. In most cases, median is better. We'll discuss why median is better shortly. So you can replace it with mean or the median, or you can use a grouping method. So you have a column here, you have a column here, you have a column here, you have another column, let's call it the y column, and this is a categorical variable. Let's say this is a categorical variable. All right. Some data points are missing here. Some data points are missing here. And say the y here has two different possible categories. All right. Say lone default, and not default. Two different categories. Default, not default. Default, not default. All right. Two different categories. You might want to compute, say, if this missing value belongs to a not default class. Instead of taking the mean of the entire column, entire x column, you might want to take the mean of all the rows that belong to not default and use that mean here. Likewise, for default rows, you might want to take the mean of all the default rows from this, mean of these columns, and take the mean of these columns and put it here. Right. So this is a grouped mean rather than taking the mean of the entire column. So that is another approach. If it is a categorical data, you might want to replace it with the most frequent data, also called as the mode of that particular column. That's another very, very naive way of filling up the missing values in categorical data. We will look at more detailed methods very soon. All right. So before we step into the approaches, it's a very nice function called data frame summary from the package called data tile. This used to be what is called the pandas summary package. Right now it is called as data tile. All right. If you might want to pip install data tile before using this. Now this one will give you a very nice summarization of the percentage of missing value in each of the columns in the data set. So this credit score has 0.01%, gender has 0.14%, 0.37% here, 0.4% over here. Likewise, it will tell you how much of the data is missing in each of the columns and what is the type of column. Is it a numeric data or a categorical data also? It tells us. Quite useful, very nice summary. It also tells us the counts of non-missing values also. Very good way of summarizing the data. When you are doing missing value treatment, this is a very useful function. Now, let's get on with the various approaches. Many of the approaches are going to be very straightforward. Approach 1 is dropping the rows that contains missing values. Right? If say age is one of the columns in the data, in those rows that contains age, we are going to drop that. So age dot null will tell you which of the rows of age are not missing and keep only those rows. Alright, and that's what this one does. And if you want to remove null values, remove missing values in more than one row, add all those age dot null and ampersand and balance as well. So based on these two rows, if age is missing or balance is missing, both of them, the rows that contains either age or balance is missing, those rows will be dropped. Alright, so by doing that, we are solidly missing, I think 77 data points or rows are getting removed here. Alright, so that is another approach. Second approach is fill with zeros. Fill with zero. Now, for example, that's a column called balance in the data set, right? Now, if the balance data is missing, it could be a logical thing to say that the balance of that person is zero at that particular point in time. If that is the logic the bankers decide to go after, you might want to check a few records of people whose data is missing, and if it turns out to be there is no balance in those accounts, then you might want to replace. Just do a few random checks with the actual situation in the real life, right? Do those checks, and if it turns out, okay, if those values are missing, you might want to replace those values with zero. This might be appropriate for balance, and similar variables, you might want to go one after the other. In those situations, what would be an appropriate value to replace the missing data with? You might want to take a judgment call here. In this case, we are just filling it up with zero. Yeah, just use the fill NA function and put 0 here. That will fill up the values with 0. Now, alternately, you could go for the most frequent value. One example, this is not a recommended method at all. This could be a last resort. One very crude way of doing this is, say, for the gender column. So this is a categorical variable. It's either male or female, right? Now, if a good number of rows are missing, some of the rows are going to be missing, and if, say, in this data set 75% of the people are male and 25% of the people are female, let's say, if this is the distribution, then the records that are missing, you might want to replace it with 75%. The chances of that imputation being right is again 75%, approximately 75%. Now, if this distribution is 50-50, 50% male and 50% female, then you are going to take a wild guess. Right, you are going to be right 50% of the time and wrong 50% of the time. So this approach there's a large caveat to this of using the accurateness of this particular approach. So use it with caution. Alright, this is your judgment call. Now here you are getting the value counts. Both male and female are approximately the same ratio. So this is a hit or miss. It's going to be completely random. Our guess is going to be completely random. So since male is slightly having a larger frequency, we are going to replace everything with male, and that 50% of it is going to be right, 50% of it is not going to be right. So this is not a good approach, maybe the last resort, just an option you have. Now, another thing you could do is, instead of replacing it with male or female, you could fill it up with a standard string. You could replace it with an empty string. This could be empty, it could be none, whatever string it is, just replace it with a standard string. And this becomes a third category. As per your machine learning model, it will know that these records were missing in the first place. Yeah. So that is another approach. Now, before we move on, what could be a better approach? Now here in this data, this is customer data, and this is for specifically for the gender column, right? You might want to remember this. For the gender column, the chances are you might have a column that contains the name of the person also. Here we have a surname column here. Surname is here, right? Now, a better way to fill up the gender column is, the surname might give away what could be the gender of the person, depending on the surname itself. Maybe in certain cultures, surname is going to be the family name, which is gender neutral. But if it is not the case in that particular region or population, then this variable could be helpful. Sometimes a better variable could be the full name. You could use the full name and refer to say a baby's name dictionary. Like you have names for male boys and names for girls. You could form a lookup table, and if say Hill is present in boys' names, you might want to replace the gender. So in this case, Bonnie, right? Bonnie is missing here. Sounds like a female name, right? You might want to look up the baby's name table, and from that you might want to arrive at what is the gender of this particular name. All right. Now that is one other method. An alternate, slightly more smarter thing to do is, sometimes if your full name contains salutation, it contains Mr. name of the person, or Mrs. name of the person, or Miss name of the person, whatever it is, from the salutation also you might be able to arrive at the gender. All right. So that is another way you can handle this kind of missing values, especially for gender. This is a technique that you can always use. Yeah, let's move on. So that is the standard string approach. Next one is filling it up with the mean and the median. We have already seen this when you can, so if the data is completely missing at random, so that is one place you could use this method. Or if your data is normally distributed, in that situation also you could use the mean or the median or even the mode. Yeah. Now, where the problem arises is, suppose instead of being normally distributed, your data has some good number of extreme values, have a long tail. There's a good number of extreme values existing in the data. In such a case, if you take the mean might not come here. The mean might not come here. The mean might be situated over here because of these extreme values. Right? In such a situation, you might be better off using the median instead of the mean. Median might be closer to the actual peak of this distribution. All right, so that in that case you might want to go for the median. Median is a better representation when there's a majority of values in a given, when there are extreme values in this case. All right, so that is another approach. Alternately, you can impute it using the mean or the median based on the group. We have already seen this approach. That is, let me quickly recap this. So you have the data, you have the X, you have the Y. Y has two categories, default and non-default. Remember, we just saw this, default and non-default, default, non-default, like that. If a data is missing here, take all the default rows, take the mean of the default rows alone. So suppose this is default, take all the default rows, take the mean or the median, typically the median, take the median of the default rows and fill it up here if this is missing. Same applies for the non-default also. So group the data and then use the mean or the median of those groups to fill up the missing values. Yes, that approach is this. Implementation is quite direct. So here we are trying to impute the balance variable based on gender. So what's the balance that females have versus what's the balance that males have? So first, group by based on gender, get the balance column and transform to get the mean. So this particular column will have two possible values. This is for the females and this value for the males. All right. Once this is computed, you can use the np.where function. If balance is missing, then take the value from the balance by class. If it is not missing, take it from the original balance column. Right. So if this is missing, take the value from the balance by class from this column. If it is not missing, take it from here itself. That's what this logic is. You can use that to create the imputed balance column here. All right. So that column is towards the extreme, towards the right here. This is the imputed column at the end of the day. All right. Next one is interpolation. Now interpolation is a beautiful approach to fill up missing values, but you need to take care of certain caveats when certain things you have to note and be careful of whenever you want to use interpolation. You cannot use it for all the situations. I'll tell you what are the checks you need to do. All right. So interpolation itself, the default way of interpolating is called the linear interpolation. First we will look at linear and then we will look at non-linear. Yeah. In linear interpolation, you can apply interpolation in the first place when you have two values, two columns. You have an X, you have a Y. All right. Now there should be, you should have two columns, two data here to do interpolation. The X we call as the index also. all right, and there should be some sort of an ordering inherent to x. For example, take this data. You have first class fare is 100, second class fare is missing, third class fare is 60, open class fare is 20. All right. So we have a missing data here. But this we are taking as the x, and this is the data that we are taking as the y, and there's a internal inherent ordering to the x here. So you can take it as when x equal to 1, the value is 100. When x equal to 2, the value we do not know. When x equal to 3, the value, let me write it as k here, all right, so it's not x. When x equal to 3, the value is 60, x equal to 4, the value is 20. This way we can transcode it, all right, and there is an inherent ordering to the x. And before applying interpolation, you need to make sure that this column, this x column is sorted before you apply the interpolation. So you can do that very easily. The interpolation, you can do it very easily using the pandas library. You can first store the data as a pandas series. Nicely, this dictionary is converted to a pandas series. Now, series has a function, has a method called interpolate. If you call this method, it will do a linear interpolation by default. Now, quickly, what is linear interpolation? What's the formula behind it? Say you have one x here, you have x naught here, and x1 here. You know this data point, you know this data point also. These are known data. Both of these are known data. You have this data point as x naught, y naught, and this data point as x1, y1. All right. You can, if this x is known, you can find the value of y. And how do you find it? You have a standard. This is an equation you might have learnt at school. So here, this formula is written for x1 and x2. You might want to replace according to this diagram. You can put x naught here in places of x1 and y naught here, and x2 is x1. If you want to refer to this is y naught, and x2 is x1 based on this formula. The diagram, I mean, not the formula. All right. So by substituting this, we will be able to compute the value of this y. The value of y corresponding to the y-axis here. Now, to implement it, just simply call ser.interpolate, and that is going to replace the value. Here, 80 is what is getting predicted here. Now, that was linear interpolation, but so the major assumption here is when we are interpolating it here in this formula, we are taking just a very simplistic case. We are taking just two data points. But the interpolation that ser.interpolate did, it considered one more data point here, all right, and it is assuming that the relationship between all these three. Okay, it's not taking the additional data point, but we do have an additional data point here. Now it is considering that the relationship between this and this is going to be linear line. This can be connected using a linear line. Forget this part. This part is not considered by linear interpolation. Forget this part. The third point is not considered. It is just taking that. It's just taking these 2 points and trying to find the missing value based on a linear relationship between the x and the y. But that might not be the case. In reality, there also exists a third point here, right? A third point here. So this might not be a line at the end of the day. It could be like this. This could be the equation. So there's a point here. Let's say there's a point here. This could be the equation that best represents this line, right? Putting this point also in context, the shape of this relationship changes. It's not linear anymore. So for this x, if you want to find the value of y, it falls here. So this should be the predicted value of y, isn't it? Putting this point, this new additional data points into context, the predicted value changes. And that is exactly what spline interpolation does, right? In spline interpolation, you just specify the method equal to spline, and set the order. If you set order, it will try to make a quadratic equation. The equation of the line in linear interpolation is going to be a linear equation, that is like 2x plus 3y equal to some number. This kind of an equation will be there. When you set order 2, there will be the x will be raised to the power of 2. Right? When you say order 3, you will have x power 3 plus x square. These kind of terms will come. Alright. Now, if you keep increasing the order, the closer it is going to get. So, if you have a complex set of data points, it might try to fit the data points as close as possible as you keep increasing the order of this equation here. And if you reduce the order, it will try to generalize this fitting also. It will try to generalize it and make a reasonable estimate. So that is spline interpolation. The implementation is still using the interpolate function, use method equal to spline. This is also available in the data frame method also. Using data frame object also, you can call interpolate, set the spline method equal to spline order 2, that will still work. Now see here, the prediction based on spline is not 80, it is 86.66 here, which probably might or could be more accurate. Alright. Now, so those are the various approaches. We also want to discuss one more approach called the forward fill and the backward fill, and this will apply specifically for the cases of sequence data, especially time series data, right? When you say a sequence data, when there is an ordering in which the data seems to occur, especially in time series. Time series is something like, say, the weather data. You have day 1, day 2, say this is days, and this is the temperature, max temperature, right? Day 1, day 2, day 3, day 4, day 5, and such, so on and so forth. And you have the temperatures here, and suppose if a particular temperature is missing for a specific day, forward fill is, you take the previous value here. Suppose this value is, say, 32. You will take this value and apply it here forward. This is forward filling. Backward filling is, suppose if this is 41, you move it backward, and this data point, instead of being 32, you would predict this one as based on the next day's value, which is 41. Now, this approach would not make sense if there is no specific sequence to the data here. Without this day in context, suppose you're not dealing with days. Suppose you are computing or capturing the temperature for, say, iron rods that is coming out of a manufacturing process. So various iron rods are existing. There is no sequence to the iron rods here. It would make absolutely no sense to sort of forward fill the data. So this could be rod 1, this could be rod data point 2. So various different rods are there. There is absolutely no sense in forward filling in a data where there is no inherent sequential information inside it. So those are the various fundamental approaches of imputing missing data in a given raw data set. In the next one, we will see how to predict the missing data using a predictive modeling or a machine learning approach using an algorithm called MICE. In the next one, we will look at the exact logic, exact step-by-step algorithm behind the MICE imputation approach.